Okay, here we are at our final unit for the gas tungsten arc welding class. This one is all going to be done on your own. I will just go over some of the notes that you take in your theory manual. So make sure you have that out at this point. The PowerPoint is going to pretty much follow what you do in that theory manual and the answers that you need. So here's a couple tips for studying for this unit. You need to watch this video more than once, and once in a while you're going to have to pause to take notes where necessary. Don't just watch the video once and try and scribble down a bunch of stuff as fast as you can. That will not work. Follow along with your study guide, but don't just write down what fits in the blanks. Take additional notes. There's more in this PowerPoint presentation than what's on the study guide, and there's more to the test than that. So don't just fill in the blanks. When you see something highlighted in red, you should know that will be right on the test. Hint, hint. Lastly, don't copy this presentation word for word. That's going to make you miserable, and it's definitely unnecessary. So let's get started. Hope you got your study guide out. So we are going to talk about gas tungsten arc welding from a quality control standpoint. One of the main reasons this process is used is because you can produce high quality welds with minimum impurities. So we have a couple of challenges with trying to be able to do that, as you might have experienced already. There's a very low tolerance with this process for contamination, and that's going to cause some problems for you. So a lot of what we're going to talk about is contamination related issues. So let's get over some key terms that you're going to need to know. Of course, welders and people involved in the welding process should always repair discontinuities whenever they are able to. However, look at the definition here. A discontinuity is an interruption in the typical structure of a weldment. So it doesn't mean that the part has to be rejected. Should you fix a discontinuity? Most likely if you're able, but it doesn't mean that the part is junk. Now on the other hand, a defect is a discontinuity that has surpassed the allowable limits for acceptance. So in an inspection, a quality control person could say, okay, we have a discontinuity of a crack, and the allowable limit is 1/8 of an inch per crack in an inch of weld. And if we have a crack that goes over 1/8 of an inch, that discontinuity now becomes a defect because it's past the allowable limits. Here's a point highlighted in red. Defects are the issues that must be resolved before the weld is put into service. That's defects, not discontinuities. So we got a list of some other discontinuities that could happen during gas tungsten arc welding, and I'm sure you've experienced a bunch of these. This is a list that you will need probably in your study guide, right? I think question 2 or 3, maybe question 3 is asking about a list of the other discontinuities that could happen while you're doing gas tungsten arc welding. So make sure you write these down and make sure you have some blank space to take notes about each one of these. You're going to see some questions about that further along in your study guide. Let's get started with excessive electrode consumption. This seems to be a chronic problem in our class. A second class especially comes in and they say there's no electrodes left for welding. What's happening? Is somebody eating all the tungsten? Not likely. Somebody's probably not stealing it either. Maybe a couple you are. Anyways, though, let's look at some of these causes and fixes. Okay, welding with DC electrode positive. Electrode positive, let's see, that's reverse polarity. So all your electricity is coming up from the base metal into the tungsten. So it's pulling all that energy up in the tungsten and probably eroding it away. That's a problem. Change to DC electrode negative. Here's another one, exceeding working amperage for electrode diameter. So if you have a small diameter electrode and you're trying to use a lot of amperage with it, that amperage is just too much power for it. It's probably overheating it and it's going to wreck it. So let's see, the other ones here, contamination, electrode oxidation during cooling, shielding gas contamination. These are kind of contamination issues. So one of these fixes for contaminated tungsten electrode is just to remove the contaminated portion of the electrode and regrind. Even if you don't contaminate your electrode, you're probably going to have to regrind every once in a while just because your tungsten's eroding. But that's something you should be doing. And using the proper shielding gas and the proper amount of shielding gas is another way to combat problems with electrode consumption. And then again, not stealing all the tungsten is probably another good thing you can do. But definitely that's not one on the test. So here's one that's definitely on the test though. It's highlighted in bold red letters, erratic arc. An erratic arc is a welding arc that wanders from its intended path, like you can see in this picture. You have a electrode that's kind of ground incorrectly, and then you see those little blue lines. That represents the arc jumping off that tungsten electrode from different spots instead of right down here from the point in the middle. So some of the problems that cause erratic arc are when you have a contaminated electrode. That one happens a lot. I tell some of you, just stop, just be patient. If your electrode is contaminated, stop and regrind it. It's going to make a world of difference and you're not going to wreck that weld. Another problem, tungsten ground in the wrong direction, like in this picture. So you want to grind so that the lines are facing up and down with this tungsten, not like this one is ground. And there's a couple other little issues on here. Just take note of some of them. On the test, you may have to describe what could cause an erratic arc and what you could do to fix it. So go ahead and pause the video here and take a couple more notes about this slide. Porosity is something that we don't really encounter so much in this class so far, but it's something worth mentioning because it can happen. Usually porosity has to do with a shielding gas issue or any kind of contamination issue. So if you look at the first cause, there are trapped gas impurities. Porosity can be caused by hydrogen, nitrogen, water, air, any of those kind of things getting in your weld. So you want to make sure that you have enough gas flow to protect your weld, not too much to create turbulence. You want to make sure that your arc length is close enough so that you don't lose your shielding gas. And then again, you want to make sure that you're not welding in a drafty environment where you might get a breeze that's blowing away your gas. And then again, you should always be cleaning your material. If you had any kind of water or oil or something on the base metal, that's going to cause contamination as well. Just make sure that you don't leave anything behind, especially those oxides. Now we got a big one here, tungsten inclusion. This tends to happen a lot when people are first learning how to weld. Tungsten inclusion, hint, hint in bold red letters, is a discontinuity only found in the gas tungsten arc welding process. Hard to get tungsten inclusions in wire feed or stick welding if you're not using tungsten. So this one should be quite obvious on the test. So here we have a picture of an X-ray. An X-ray is a common way to inspect welds internally without destroying them, without cutting them apart. The little white dots are showing tungsten that becomes entrapped within the weld, and it can possibly cause cracking just because these two metals don't seem to go together very well. And it's a little spot there where you put stress on something and you got that little spot of something else in there. That's a cause for an issue, and usually welds that have this kind of discontinuity are rejected. There's not a high tolerance for tungsten inclusion. A couple more things about tungsten contamination inclusion that you should probably think about. So here's the circumstance where you may dip your tungsten into your weld pool and it becomes stuck in there, or it melts off like half your tungsten. This is one that I see a lot in our classes when you're just first practicing and you're not very good at this. There's a couple different things that you can do other than studying your hand. You can also use a high frequency arc start like we do, and not use like the touch starting method. It's kind of old fashioned. All our machines have a high frequency start. And you could also use the proper electrode size for what you're doing. If you're using a really small tungsten electrode and a lot of amperage, chances are you're going to have a higher risk of sticking that electrode into your weld pool. And kind of like the third fix says, just keep your tungsten out of the weld pool. It's a lot of practice. That's why it happens a lot when you're first learning. When you get better at it, it doesn't happen so much. And in bold red letters, we have the discontinuity of cracking. Why is that? Because cracking is the most undesirable of all these discontinuities. Cracking completely wrecks a weld. There is no saying that, oh, well, there's just a little crack in this weld, it'll probably be okay. No, a crack is going to cause the weld to continue to fail. You'll see cracking a lot in welding aluminum. Sometimes some types of aluminum aren't very weldable, meaning they just don't blend together very well. So you have to pay attention to the numbers on that filler rod of aluminum. What kind of aluminums are you trying to put together? And then too, like if you think about aluminum and its hot shortness, adding too much heat to something, okay, you may have to do some heat treatment, so a preheat or a post-heat treatment. And some of that stuff, when you get into metallurgy classes, you'll find out that some of those things are a little bit of tricks to remove some of the internal stress that's in a metal. And it's kind of like the cause where it says too much restraint within the weld. If you have to put pieces together and use a bunch of clamps to hold it together, chances are when you put a weld on that, it's going to hold all of that pressure inside, and when you let go of the clamps, it might be too much for the weld and it might crack. Incomplete fusion, here's another one that we could commonly see. So incomplete fusion happens most often in gas tungsten arc welding when you add too much filler rod. And sometimes I think that tends to happen when we're welding aluminum, just because that filler rod melts so easily. And if you don't get the base metal melted, you're basically just plopping filler rod on top of your metal, kind of like this picture here of the overlap. And I've seen it more to an extreme case too, where the filler metal is just plopped right on the metal and it's not even really biting in. So a couple of things you can do are adjust the amount of filler metal you're adding, and also crank your amperage up. It says welding voltage too low. It also means like welding amperage could be turned up too. So that's the easiest thing to control. You can increase your arc length to increase voltage, but more easily you can just crank your amperage up a little bit so that you're melting your materials a little bit better. But incomplete fusion is something that's common when you're first practicing and just getting down the technique. Oxide films. I still think there are some people in class that don't understand that they need to clean their metal before they go to try and weld it, especially the aluminum. The stainless steel we have is pretty clean and it's not got a lot of contamination on it, but the aluminum is contaminated enough that you need to clean it every time. Just get your stuff set out, get a wire brush on it, or take it over by the sander. Do anything. When you stop welding, you have to re-clean where you're going to start welding again. Some people, I don't know why, they just don't get that. They think they can just go ahead and weld and get through it, and usually that's when they have half a weld that's good and then the other half isn't quite so good. So if you're struggling with that yet, just stop, slow down, and clean a little bit better. So you know that oxide films are caused by the reaction of aluminum to oxygen. That's normal. It's always going to happen. Couple of the fixes that they talk about obviously are clean your metal, change to AC if you're not using AC for aluminum. Some of you probably tried this and you know that you get a picture like the one shown. And also be attentive to the shielding gas you're using, the type of shielding gas and how much shielding gas flow. Not enough shielding gas or too much shielding gas can lead to either contamination from the atmospheric air or turbulence in your weld, which is not helping clean it out, because you know, right, that the gas does some part in cleaning out your weld. All things to pay attention to. So that is the end of what I have for this unit for you. We will take the test at the end of this week, so make sure that you have this unit done before Friday. We'll check it probably on Thursday so that you have a chance to make sure your answers are right and study. I'll also be collecting your theory manuals to give you a grade on each one of the units. So make sure that you have your theory manual complete by the end of this week. And then after that, we'll just be welding for the last week.